Let's do our last examples. Now, you'll notice pretty quickly that these examples are very different from everything else we've done so far in that there are no numbers here. Now, anytime you get to a problem that doesn't have any numbers, we've got letters only, and I don't count the 2 in B. I mean, like, there's no angle here. There's nothing for us to plug in. Instead of doing it on our quadrants like this, we are going to build a right triangle and go old school with SOHCAHTOA. So, build a right triangle anytime you've got X's instead of numbers. That's kind of the moral of what I'm trying to get at here. So I have my right triangle. I'm going to think old school SOHCAHTOA. Now, next thing I want to do is I'm going to take my inside expression and I'm going to call that theta. So I have theta equals arc cosine of x, which I know is the same thing as cosine of theta equals x, just like we've been doing before. These two statements are totally the same. We just moved the cosine to the other side. Now I'm going to, just like I did in the last problem of the last video, use this inside one to build my triangle. So I'm going to use this inside statement to build my triangle. Now I know I can put that x over 1. And remember, we're thinking old school, SOHCAHTOA. Because this is cosine, this is adjacent over hypotenuse. So I'm going to find my adjacent side and call that x. Find my hypotenuse, call that 1. So I used the inside one, changed it around, and then used that in SOHCAHTOA to build my triangle. Now let's use Pythagorean's theorem to find our last side. We have a squared plus b squared equals c squared. So b squared equals 1 minus x squared. And normally we would have plus or minus on this square root, but because we are dealing with a right triangle, which is distances, we don't need the plus or minus because distances can't be negative. So that gives me this is this side. So I used the inside to build the triangle. Next, I'm going to use the outside to answer. So now I want to find the tangent of this triangle. Well, I know that tangent of this triangle, tangent is SOHCAHTOA. So the opposite side is this one. And my adjacent side is that one. And that is my answer. So I used the inside to build the triangle, used the outside to get my answer. Now, one thing that the instructions also state that we want to do is it asks about the domain of this answer. So what we're going to start with is the domain of the inside, which we already listed down here in our domain chart in the last video. So our inside is arc cosine. So that would be this one. So my base domain is -1 to 1. Your base domain is whatever the domain of the inside function is. Then what we're going to do is take the base domain and restrict it using the answer we got here. Now this will require you to remember some 1050 things. So anytime we talked about domain in 1050, we talked about two main things. We said the inside of the root has to be positive, greater than or equal to 0, and that the denominator cannot equal 0. So I took the inside of my root, made it positive, denominator cannot equal 0. So this one is already solved for, x cannot be 0. Let's solve for the other one. Now, another little reminder from 1050. Anytime you square root, you do have plus or minus. So +1, -1. However, for the minus, your inequality sign will also flip because it's negative. So we have three rules here. We're saying x has to be greater than or equal to 1. Oh, hello, I did something wrong. My bad, guys. Let me backpedal a little bit. I forgot when I divided by a negative up here, that flipped the sign. Oh, I didn't flip the sign again. Goodness sakes. There we go. So because I divided by a negative right there, I flipped the sign. Then on this one, the sign stays the same. And on the minus, the sign flips. There we go. So now I have three rules. X has to be less than or equal to 1. X has to be greater than or equal to -1. And X cannot be 0. So what I'm going to do is modify my base domain to fit the rules I came up with. Now my base domain had to be from -1 to 1. That fits these two rules. Has to be greater than or equal to -1 and less than or equal to +1. So those two rules are already taken care of. However, I do also have this rule that x cannot be 0. So that means my final domain is my base domain, except I don't include 0, because that was the other rule I came up with. And that is the final domain for my function. So here's what I would like you to do on B. I would like you to use the inside to build the triangle. So here's what I got. I want you to take the inside. Theta is arc sine. So here I have it written out. Theta is arc sine of x, which is the same thing as sine of theta equals x. And you're going to use that inside to build this triangle. Remember, sine is opposite over hypotenuse. SOHCAHTOA. So my opposite side is x. My hypotenuse side is 1. Then use Pythagorean theorem to finish the triangle. Then think of what you now have left. We have cosine of 2 theta. Don't forget that 2 chilling in front. So what I want you to do is use one of your double angle identities we learned last chapter to change this into one of your double angle identities, and then use the triangle to answer it. So pause the video, think on that a little bit, and then we'll come back to check and see how you did. So let's look at this one. I saw opposite over hypotenuse. So opposite over hypotenuse. Use Pythagorean theorem to finish out the triangle. Now I have cosine of 2 theta left, substituting that whole thing in for theta. And I chose to use the 1 minus 2 sine squared of theta double angle identity. There are 2 other double angle identities you can use for cosine. You really could have used either of them. This is just the one that I picked. Now, also notice that instead of putting my squared inside, I put it outside. That was so that I could see that sine is opposite over hypotenuse. So I could pick the opposite side over the hypotenuse side, plug that in to get my final answer. Now let's talk about the domain. First thing we start with is the base domain of the inside function. So base domain of our inside function is arc sine. So look at your domain chart that you made in the last video. The base domain for arc sine, let's see over here, is -1 to +1. So that's why we start with our base domain of -1 to 1. Then I look at my answer and restrict it anything I need. Now remember, for domains, all we need to pay attention to are even roots and denominators. However, in this problem, my answer doesn't have any roots, even roots, and it doesn't have any denominators, which means my base domain is my final domain. So that is it. That is all we need to know for inverse sine and cosine. You're done with lesson 4.1. In the next lesson, 4.2, we'll talk about the other inverse trig functions.